All right. Next up, we have Nicolas from Telia. Um, Nicolas is a former colleague of mine, and we work together in Division X of Telia, where we, really use data insights to address the challenge and problems in different industries. So during the COVID situation, Telia has been working with different healthcare authorities to address, to monitor the population movement, because we know there's strong correlation of people movement with the infection situation. So in this talk, Nicolas will review their insights of that work. So let's bring it on. And Nicolas, welcome.
Hi. I'm Nicolas Petitclerc. I'm French Canadian. I've been living in Oslo for about 3 years. My background is a PhD in astrophysics. Since then, I work in 2 different startups, and now I work as a senior data scientist at Telia as part of the team Data Insights. Here we'll talk to you about our main product, which is Crowd Insights, and I'll say about how we've been helping out during the COVID-19 crisis with our data, and also share a bit of it more precise insights that we can find from our data in a way. So first of all, what is Crowd Insights? It's a product that provide insights on aggregated people movement using the network data knows which cell tower the cell phones are connected to. And when the person changes from cell tower to cell tower, we can infer that the person is moving around. So that gives us an idea of the location of people. And of course, it's on a cell tower basis, and cell towers have a certain coverage area, ranging quite a bit from a few hundred meters square to a few kilometers square. So really here we're more about the big picture compared to GPS-based geolocation data. But compared to that, we have a strong advantage is that we are Telia has about half the market share in Norway, and throughout our footprint, we have significant market share. And of course, Telia take great care to preserve anonymity in this data, and privacy is important, and I'll say a bit more about this. But more concretely, what it means in terms of the type of metrics that we can get out of this is about the trips, where we provide the origin-destination matrix, which is basically the count of people going from region A to region B, where the region can be anything we want to. It can be municipalities, counties, Grundkrets, or any combination of those. Another metrics we can evaluate is the number of activities. So we define an activities as when somebody spends a certain amount of time at a certain location. For example, if somebody spent at least 20 minutes in some area, we can infer that that person probably did something in that area, like shopping or whatever it is. And the other metrics we can follow is what we call footfall, which is basically the count of unique people passing by the area. So not necessarily having activity, but to time bins. Typically we work with hourly, but sometimes we can go to daily as well if we need better statistics. So as I said, privacy is key to us. So I will tell you, our team is a little bit like a startup within a corporation. So basically, and lots of care about privacy is throughout the organization. So data is already anonymized before we even get to touch it. So by anonymize, I mean in 2 different ways. One way we identify the user is by the IMSI number, but this IMSI number is hashed before we get to see it. So basically just get an ID number per person, and then it's also anonymized that we apply K5 anonymization, which is at least need to have at least 5 person per whatever metric we're looking into. and um, the way they anonymize it is at the cell tower level. So you need to have at least 5 persons connected to a cell tower in an hour time frame for us to even get the data. Okay, so that's even before it gets to us now. What we do with this is we aggregate these I just described, and this is done in collaboration with Winocast, who's the workhorse behind all of this. And also, so we aggregate this on those metrics, and we also need to extrapolate those numbers because we have certain market share of the data. So that already increased a bit the noise level on our data. And on top of this, for each metrics, we need to reapply K5 again. So it's really quite this as well. The hash value is that what the salt is changed every 24 hours, so we cannot track for any person for more than 24 hours. Okay, so hopefully I convinced you that it's quite well anonymized. Now our data has been quite popular during the COVID crisis. Lots of newspaper want to get our data to write stories about it. So this shows that there's some importance to it. And it was very popular in Sweden and Finland, Norway a bit less, but at least we got a pretty good article in Tech.no. So it showed that the people are interested in this type of, and we also needs. So one very interesting application of our data was that the Danish Health Ministry, who used our ODM, use our data also to monitor the impact on the restrictions. And see, just show some example of dashboards that we provided for these people. Here you can see that also municipality in particular request this dashboard to track the number of trips between each region within the Oslo municipality. Also, an interesting case is the Estonian government, who initially just basically asked telco to give them all our data, and also because they don't want to give away their data, and also because it's huge privacy issues. So instead of just giving them the data, what we did is we did the analysis that they wanted for them. And that was mostly about monitoring whether people were following the restriction, how far people move and traveling, and things like that. Then provide some communication material to find out the hotspots, places that people should avoid because there's a lot of people and where it's more densely populated. So they provided on the website, they provided a map basically of areas that the people should try to avoid. Okay, so now we're going to dive a bit more into the insights that we can get from our data. Overall picture, big picture that we provide for free. You can see it's updated. You can, if you scan this QR code, you're gonna get to the web page where this is updated. And you can see that the major trend, this is the change in number of trips over time. It's very quick and quite strong, going down to 30% less traffic countrywide. For Finland and Estonia was somewhere in the middle, and Sweden was a bit slower and a bit much less reduction in terms of traffic, so more around 20%. And since the beginning, Norway and Denmark, the traffic, and now it's interesting to see that it's actually higher now in Norway and Denmark than it is in Sweden. So we're closer back to normal than they are in Sweden. Okay, so now I deep dive into the municipalities. So I plot here the top 10 municipalities in terms of traffic, and color-coded the one with most traffic in dark. And you can see the pattern that's going to be recurring throughout these next following slides, that the areas with higher level of traffic has higher decrease level, and it kind of makes sense because it's mostly where people work, and most people work from home, then this area decreased a lot in terms of traffic. I'll also look into the different type of traffic, traffic within the given municipality, or traffic from outside of the municipality, so between different municipalities. And I saw that the change is, the decrease is much higher for the trip outside of the municipality, meaning that probably people make much more shorter trips than they used to. So for the next following, I'll show instead is the total distance travel. So maybe a better metric of a traffic change. So here it's a busy plot, but it's interactive plot that usually it's interactive. I cannot make it interactive on the presentation, so I'll just show a snapshot. But it shows the top 100 municipality all at once. Again, they color-coded, with the darker ones being the heavier traffic municipalities. So what we can see from the advantage, you can see them all at once, and it's easy to compare. Then it's easy to see that there's like an outlier here that's really much higher the decrease in traffic and really constant. It haven't increased yet. So I was curious into it, and turns out that it's Ullensaker, which is where the Oslo airport is. So it makes perfect sense that it's still pretty much closed. So traffic is strongly reduced. Another feature that I found interesting was these weird spikes that I noticed in some municipalities every weekend, seems like. And those are actually these plots are smoothed, so it's a bit less messy to look into. So it's a 3-day rolling windows applied to those. So, but if I remove this and just show the raw data, and which is like this, but I just changed the color scheme here, but this is pretty much the same thing, and without the rolling window. And you see that the spikes happens mostly on Sundays in those for many different municipalities. So I was a bit curious, dig into a little bit into what was about. So my first thought was it's probably people coming back from their cabins. So I took so what I thought, okay, it must be correlating with the number of cabins per municipality. So I took the data was the worst case, May 3rd, which is the Sunday after the Labor Day weekend. And I plotted the amount of distance travel change in function of number of cabins according to SSP. And there was not much of a trend at all, so it was a bit puzzled. So I looked into the top 30 municipalities and send that to my Norwegian colleagues, see if they could find any common denominator in all these places that I don't really know for the most part. So a few ideas start bouncing around. That's maybe it's the camping season just started on May 1st. So there can be lots of people coming back as well from camping. Also learn a bit about Norwegian culture, that about Norwegian likes to go for the walks on Sundays. So they call it Sundagstur, and also that creates some local tourism. And also an added factor to all this is probably the nicer weather. So combining all this, we're pretty, so working theory, but somebody mentioned about municipality that he thought was like the stereotypical type of municipality for that, which is called Kragerø. And the reason I was wondering why it didn't show up in my list And the reason is because I was just looking at the top 100 municipalities. And then when I look at all of them, that municipality happened to be the second highest rank. So that's kind of a case in point for our little theory here. Okay, so now I look into the even finer grain level data. I look at the Gunkrats level, and I just showed here an average over a week about the distance travel change. And you can see that the smaller, the more granular you look into the data, the more extremes you get. So here, if you really look in the centrum area of Oslo, the reduction gets close to 100%, like in the 90% kind of level. And on the other hand, in some areas, the traffic actually increased on average. So you can see like up to 200%. In some areas, it's mostly in the forest, so more people go hiking or go near the water. An added factor to this is probably that also nicer weather is getting warmer and so on. Okay, so I was asked to talk as well a bit about the type of tools we're using for us within our team. So for me personally, as a data scientist, it works mostly as for like the analysis, exploration, or prototyping. We use Colab or the AI platform. And all of our tools is pretty much in GCP, the Google Cloud Platform, which works very well for us. And what's really good about it in particular is BigQuery, which is a big selling factor for us. It's very powerful. It's allow us to manage all the big data aspect of our work. And it's also had lots of GI for location insights. It's really good because it has lots of GIS functions built into it. So we can, for location query, we can type query for like by distance or between different location. So that's very valuable. We also use cloud storage, of course, and then maybe for the more dev type, we also use this stack of one of our big tasks as I'm part of the engineering team. And part of the big task of the engineering team is to automate things. So we produce lots of dashboards, but the idea is we should not do it all manually. It do not require an analyst to do everything manually, so we want to automate all this. So this is a big aspect of our team, the efforts of our team. So if these type of technology excites you, then I'd be happy to hear that we are hiring a data ops engineer to help us into that. Now the only thing that we cannot do in GCP is the data visualization, because their solution is not, it doesn't really handle maps or things like that. So so instead we use Tableau. Okay, so I hope so. Basically, that's it for me. I hope I've convinced you that our data allow for better understanding of what's happening in cities and countries, and also that Telia uses data to make a positive impact during the crisis. Thank you.
Thank you, Nicolas. Super interesting. So you did mention about the hiring for data ops engineers. So how can people get in touch with you? Should I add you on LinkedIn, or should I
find you? Yeah, ping me via email or LinkedIn. Yeah, just get in touch.
Perfect. So we do have some questions. One thing is that I'm personally wondering if there's any future plans regarding AI and machine learning. Obviously, you have fantastic data set. So if applying machine learning, I think that would be unveiling even more insights or different applications.
Yes, so I was kind of expecting this kind of question. So I have a list of, well, we work with a lot of data. So there's kind of two ways you can look at the AI and ML for us. We can be used more for improving our solution or accuracy and so on. And in that aspect, and how we process the signal data, there's lots of we apply lots of algorithm for to go from signal data ping in different cell towers to go through an actual route on the road. So that's so we do apply some routing algorithm for this. And once we do that, then we can also think about trying to do some type of classification about the mode of transport that the person used, whether they use a train or a car or bike or walk or flights. Some are easy, and we have some. Well, something we're working on right now. It's not easy because our data is quite, our geographical accuracy is quite large, so it's not that easy to infer those things. But some are easy, like flights or walking. But between cars and trains, it gets a lot more tricky, or bus. So that's the type of things we're working on. Something I'm also interested in, maybe more for application or for, say, retail application, would be to, I'm talking about something else more, but also for, like, say, when we define activities, whether somebody stayed in an area or not, like some kind of clustering that we do, and we also apply some filtering to remove the noise, typically Kalman filter. But also, we can also try to, from this data, we can also use AI to, like, make this data even more useful. So that's when we can start thinking about things like forecasting, which was something that people requested in the context of the coronavirus, especially, where some people were interested in building apps where you could monitor where the people are, so to try to avoid the busy area. Unfortunately, we don't really have live data. Our data takes some time to get processed. We get daily batches and so on. So one idea was to do like a short-term kind of prediction to know, at least be able to know what to expect right now. So I did some experiments on this using a Prophet library, and it works very well actually for short-term prediction, because we have very strong signal in terms of hourly pattern is very clear pattern, very smooth, and also a daily, a weekday pattern is very clear as well. So what's trickier is, say, for holidays or like longer trends or summer versus winter. This kind of thing requires a bit more data than historical data than we have right now. But that's something we're working on. And if you can model the data, then you can do some anomaly detection. That's something I'm working on as well. And also something that I thought would be interesting as well, maybe more for retail application, is to do more area type of classification. So try to inferring from the, say, hour of the day where the area is very busy or not, trying to infer whether it's a residential area, a place with offices, or more recreational, or a place for entertainment, or this type of things. So that's the kind of ideas that we're working on. And of course, we're open to different ideas.
Right, perfect. So I mean, there's one question in the chat window. So since you guys are working with public authorities, they were wondering if there's any sort of data sets or insights which are publicly available.
Well, the data sets, we did provide some data sets for the in terms of hackathons that happened in Sweden and Norway, which was like the number of activities, hourly activities report. So that's open. And what else? Well, say high level insights. There is these this plot that I showed that have. And there is also some dashboards for each, with a bit more information for each country. So maybe I can share that in the chat window later, links to those those more detailed dashboard.
Perfect. Perfect if you can share directly in the IM window. And feel free to comment or chat with the rest of the audience. Thank you, Nicolas.
All right, thank you.